Okay, so the first chapter is all about the background to data analysis. The first chapter is going to look mainly at vocabulary, which you read about. And then we're going to look at some basic ways to display data. So today we're going to talk about the vocab. And then over the next 2 class periods, we're going to talk mainly about graphs. So you have data. How do you display it in a graph? That's a summary of the data. And then we'll look at some numeric measures. The way I organize your packets, the front page is always all of the objectives. I think this is helpful because then when you're studying for a quiz or a test, you can just go down the list and say, do I know that, yes or no? What do I need to go back to? So today, intro is vocab, and then we're going to look at categorical data specifically. It's going to have some vocab, but it's also going to have some graphs that we're going to look at, and we're going to talk about how to interpret those graphs. Besides the front page, the next thing that you're going to find is you're going to find multiple choice practice. This is not something that you're assigned. This is something that I will use if we have 4 extra minutes at the end of class. I might say go to the multiple choice, let's do a problem or 2. So that's what you'll see there. And then eventually you'll get to the note page. You guys have a few more, I think, that you have to go through before you get to here. So what we're going to do today, we are taking notes on both the introduction and 1.1, which is the categorical data. And I think you read both of those. So let's jump right in. First thing that we're referring to, and we heard these in the warm-up, are individuals and variable. So here's what we mean by each of those. Individuals are the objects described or studied in a set of data. So in that first warm-up problem, our individuals were the individual, the 35 students in the class. And then a variable is an attribute that can take different values for different individuals. Key word here that's important is can. It doesn't necessarily. So let's say that I wanted to study the average grade level of this class, and I asked each of you individually, what grade level are you in? With the exception of one, you're all seniors. So if I ignored the one that's not a senior and asked the rest of you, what grade level are you? Grade 12, grade 12, grade 12, grade 12. Theoretically, could be a different age, but because they're all the same value, that's still a variable. Okay, a super, super important word that you are going to hear all throughout the year is distribution. This is a really, really key word. A distribution tells us what values a variable takes and how often. Okay, so then we have this sample data set here. For this sample data set, we're looking at some various models of cars, and they're MPG, they're miles per gallon. This is the raw data. The raw data is often not really what we care about. We don't care about each individual car. We care about mileage per gallon as a whole. So what we will do is often summarize this data, either in a table, which we don't have, or a graph. This graph is called a dot plot. The way to read it is this tells us 1 car gets 24 miles per gallon, 3 cars get 25 miles per gallon, so on and so forth. So that dot plot is an example of a distribution. So we often display a distribution in a table or a graph. Most likely it's going to be both. If you were to read a statistical paper that a researcher has put out, probably going to look at both of those. Okay, so another thing that you read about is you read about the two different kinds of variables. There are categorical variables and there are quantitative variables. Categorical variables put our individuals into categories. Categorical variables, if you were to ask your individual a question, generally their answer is going to be in words. That's not a hard, fast rule, but generally. So if I were to ask you, what's your hair color? That's a categorical variable. You're going to answer me saying brown, red, whatever it may be. Quantitative variables, often referred to as numeric variables. These are measurements. And these are generally numbers. So if I ask you how long it took you to get to school this morning, that's a quantitative variable. Okay, so when you're determining, you have a variable. If you're determining if it's quantitative or categorical, we are going to focus on the who and the what is being measured. Okay, so then above we have these miles of cars. Those are individuals. And our measurement is the mileage per gallon. That mileage right now is numeric. We measure mileage per gallon or miles per gallon. When you guys did the reading, did the book differentiate between the types of numeric variables? No, we don't think so? Okay, so I want to talk about that real quick then. There are two different types of numeric variables. The first one is discrete, and the second one is continuous. Okay, we'll talk more about this later. A discrete variable still has to be numeric, but that value or that variable can only take on certain values on a number line. So for example, if I asked you, how many siblings do you have? That would be discrete. You can have 0, 1, 2, you can't have 1.5. When I say certain values on a number line, I don't necessarily mean whole numbers though. So if, let's say you went out to lunch and I asked you, how much did you pay for lunch? And you say $7.35, that's discrete, right? You can't pay 7.357 for lunch. So even though that's not a whole number, that's still discrete. Continuous can be anything on a number line. So there's going to be a lower bound and an upper bound, but any value in between there is discrete. So the example of how long did it take you to get to school, that's discrete, right? It could have taken you any value of time between 0 and 20 minutes, let's say. Good so far? Okay, this next question is one that's going to require you to do a little bit of thinking. Do we ever use numbers to describe the values of a categorical variable? Do we ever use numbers to describe the values of a categorical variable? Another way to think about that is, are there numbers that represent something that's not being measured? Like what? What can you think of? Numbers that don't represent something that's being measured. Evan?
Someone's address?
What part of their address?
Like the number part?
Okay. There's two parts of the number part. There's the street address, like your house number, right? Which is an example. It's also your zip code, right? Your zip code's not measuring something. So zip code, that's a number that's actually a categorical variable. Can anybody think of something else? Your social security number. That's a good example. Your student ID number. And there's more. But what I'm trying to show you here is just because you see a number does not mean that it's a categorical variable. We have to think about it. Does that number actually represent something being measured? No. Okay, so then, do we ever divide the distribution of a quantitative or a numeric variable into categories? So do we ever take numbers and split them up into categories? Yes. Like what?
Was like in the book, one of the examples was like 2 to 4 years, like they lived in this house.
Okay, yeah. I'm gonna say time. Time. Oftentimes your test scores are divided into categories. When you guys take standardized tests as a school, what we care about, right? Of course we care how you did as an individual, but in general, when we're summarizing the data, we want to know what percentage of students fell below a benchmark or below grade level, who fell at grade level, what percentage fell exceeded expectations. Often height or weight tend to be put into categories. Okay, so what's important here, besides being able to recognize if something is categorical or quantitative, is when you take your raw data, you need to ask yourself, what do I want from this? Right? So don't just look at, is it categorical or numeric, but how do I want to use it? So this depends on how you want data. So how you want to use the data, you have two options. If you want a percent of some type, like a percent that falls in a certain category, then you will treat the variable as categorical. Numeric variables, on the other hand, we often will calculate average. So if you want the average, then you will look at the raw numeric data. Okay, questions for me before we look at an example? Okay, so top of the next page. Below is information about 10 randomly selected Canadian residents from the 2000 census. What you're going to do when I'm done talking is with the person next to you, you are going to do A and B. We're not going to do this activity, but you're just going to do A and B. So you've got, I don't know, let's say 3 minutes. For the quantitative, the numeric variables, I do want you to identify if they are discrete or continuous. Okay, best of luck to you. Okay, let's start going over this. Who are the individuals? Who are the individuals? Augie? Oh. Augie, yeah. Okay, 10, randomly selected Canadian residents. Okay, walking around, not every one of you had each individual piece of this. I'm going to be very explicit when we take our notes in terms of what you will be expected to do on the AP test. And some of it is going to be pretty picky. On the AP test, if you were to write Canadian residents, you would not get credit. Why do you think that is? Any idea why if you wrote Canadian residents, you wouldn't get credit? Michaela?
It's not all the Canadian residents.
Exactly. We're not looking at all of the Canadian residents. We're looking at these 10 only. Similarly, if you wrote 10 residents, you're not going to get credit. Because residents of where? Now, is that very picky? Yes. Right? It is what it is. But you're going to have to be very specific. So at a minimum, you need 10 Canadian residents. Randomly selected would be great, but if you didn't put that, fine. Hopefully we notice everything in the table is all of our variables, so we're just going to go piece by piece and say what kind they are. Province, categorical or numeric? Categorical. Gender, categorical. Language is spoken, numeric. And is it discrete or continuous? Discrete. Are you okay that I'm being lazy and just writing at the top of the table? Handed, categorical. Height, numeric. Discrete or continuous? Continuous. It looks discrete because they were all rounded to whole numbers or a half, but you can be any height between a certain amount and a certain amount. We can't necessarily measure it as accurately as we would like, but it is continuous. Wrist circumference, same thing, numeric and continuous. Preferred communication, categorical. Travel to school in minutes is numeric. Is that one discrete or continuous? Can it only take on specific whole numbers on a number line or like 22.5 minutes, or can it take on anywhere between what we consider reasonable values? Anywhere. Yeah, this one's continuous. So again, those numbers are rounded, but theoretically it could take you 24.997 minutes to get to school. That was the intro with the vocab. Questions for me? Here's what we're going to do then. I want to talk about a few more pieces of vocabulary, and then we're going to take a break, and then we will keep going. Sound good? I'm not always the best at estimating how long notes are going to take us, but hopefully they're not going to take us the whole block, and then maybe you guys will have some time to start homework. Sound good? Okay, so what we're going to take a look at now that we know how to identify if a variable is categorical or numeric, we're going to look specifically at categorical data. So the rest of the notes is all categorical data, some things that you can do with it in a table, and then how you display it in a graph. So again, some more vocab. We need to know the difference between a data table, a frequency table, and a relative frequency table. A data table will show all individuals. And their responses. So a data table shows the raw data. Okay, a frequency table shows each category. Shows each category and the number of individuals in that category. A relative frequency table, on the other hand, same thing, but instead of showing the number of individuals in that category, it's going to show the proportion or the decimal. So oftentimes your table, let's say we're looking at what type of pet do you have? And this is our frequency. So we have people who have no pets at all, people who have dogs, we have people who have cats, we have people who have fish. And let's say in our sample, 2 people had no pets, 5 people had dogs, 3 people had cats, and 1 person had a fish. So that is 11 individuals in our sample. So that would be the frequency table. It's just summarizing the individual responses. If I wanted to change this to relative frequency, I would put 2 out of 11 here, which is some decimal. 11's not a great number to divide by, so it's something. And then you're going to have 5 over 11 and whatever that is, so on and so forth. All of those relative frequencies have to add to 1. Okay, oftentimes it's not going to matter. You can use frequency or relative frequency. I normally use frequency because I'm lazy and I don't want to change it to a decimal. But there's sometimes you have to use relative frequency. So you have to use relative frequency when you are comparing different data sets. Okay, for example, let's say that I wanted to know about the distribution of eye color in this class versus my 8th period class. You all have 28 students. My other class has 27 students. So I can't just compare 5 people with blue eyes to 5 people with blue eyes. I would have to look at relative frequency or the decimal in this class compared to the other class. So anytime you are comparing data sets, you're going to have to use relative frequency. Okay, we got 3 more things we're going to write down and then we'll take a break. Okay, so once you have your frequency or your relative frequency table, that is one way of summarizing the data, you're often going to follow it up with a graph. In this case, we're going to be looking at a bar chart. You're going to learn like probably 7 different types of graphs over this semester for displaying data, and you're going to have to know when each one is appropriate. What I need you to know about a bar graph is this is for categorical data only. Can I assume that we've constructed bar graphs before? Okay, so I'm not going to give us like step-by-step instructions. What I am going to tell us though is going to this next part is what you have to remember. So what is most important to remember when you are constructing graphs of any kind? You need labeling. So what I mean by that is you got to label both axes. You need a title. You're always going to put space between the bars. Eventually, we're going to learn a graph called a histogram that looks like a bar chart, but it doesn't have space. And so it's important that you put space in between the bars. Include a key if you need one. A key would be if you had 2 different data sets that you were comparing, like block 7 and block 8. You guys are going to need be 2 different colors or 2 different patterns or something like that. And then the last one, this one is very, very important. For any graph that we do, the y-axis must start at 0. And we'll look at y eventually, but you have to start the y-axis at 0. So don't start at a higher number because it's more convenient. Got to start at 0. Okay. Pie charts are also for categorical data. That being said, the only people that really use pie charts are the media, right? Like you might see it in an online article that has a pie chart, and pie charts are friendly for people to read, but we prefer bar charts really for 2 main reasons. first one, they're easier to construct. If any of us had to construct a pie chart by hand, that wouldn't be very easy. Second one is you can compare bar charts. But not pie charts. And I mean that in two different ways. The first way is if I just have a single bar chart, it is much easier to see the difference in these bars than it would be to see the same information in a pie chart. It's much easier to visually see it. The other thing is you can make what's called a comparative bar chart, where you can compare two different data sets. So let's say we were looking at eye color again from the two classes, and this is blue eyes and green eyes and hazel. Let's say that you guys are the class in green. What I can then do is I could then put the other class in black. And so now it's easier for us to see, okay, eighth block has twice as many people with hazel colored eyes as 7th block does. There's no way to display that same information in a pie chart. You'd have to have two separate pie charts. Okay, last thing we're going to talk about before we take a break. What are some common ways to make a misleading graph? So there's really two of them. First one is what I said above. Always look that the person didn't start the y-axis or the frequency axis at 0. That's the biggest one. The second one is using 3D graphs. Or even if it's something that's printed, if it's a three-dimensional image, that's very misleading. And it's because of how your eyes respond to that graph. When you look at a graph like this, what your mind is looking at is it's comparing the areas of those bars. But when you look at a 3D graph instead, your mind is comparing the volumes, which are not proportional one-to-one with areas. That's the issue. So those are the two most common ones. Okay. Questions for me so far before we take our break? Okay, so now let's talk more about categorical variables. So we're going to look at some more vocab, but we're going to get into actually like doing some things, not just vocab now. Next thing we're going to talk about is a two-way table. Two-way table is what you see at the right. A two-way table displays the responses for two categorical variables. Okay, so table to the right, this is a two-way table. It looks at a group of youth, young adults rather, by gender and the chance of getting rich. So we asked these 4,826 young adults, what is your gender identification, and what do you think is your chance of getting rich? So that we would say is our two-way table. So then we look at what is called a marginal distribution. So marginal distribution is going to give the percent or proportion of individuals that have a specific value for one variable. So for a marginal distribution, we only care about one variable. So there are two different marginal distributions here. we could look just at gender, or we could look just at the response that they gave. So there are two different marginal distributions. And how you would display that marginal distribution is with a bar chart. So let's say I wanted to look at response. I would make a bar chart. There would be one bar for the 194 young adults that said almost no chance. There would be another bar for the 712 that said some chance, but probably not, and so on and so forth. If I'm looking at response, I'm ignoring gender then. So we don't care how many were male versus female. Okay, if we did want to compare, though, by male versus female, we would look at what is called a conditional distribution. So conditional distribution is going to give us the distribution of a categorical variable for one category of another variable. Now, I don't know about you, but I look at that and I'm like, that's not really clear. That just kind of seems like it's a lot of words. So what I mean by that is there's two different ways that we could look at this. We could look at the female responses. So we're taking just the female distribution. Oftentimes we would compare that to the male responses. So that's one conditional with the two conditions. So looking at just the responses for females, just the responses for males. Or we could look at the response itself. So we could look at the distribution of each response separately. Okay, so if I wanted to look at this female response, the conditional distribution, I'm not going to make a great chart here because we're just talking. This is the data that I'm looking at. So I would have a bar chart, and there would be one bar for almost no chance, and then there would be another bar for some, and so on and so forth for the 5 responses. So again, the condition just being females. If I wanted each response separately, I would have to choose a response. So maybe I want to look at almost no chance. That's the data then that I'm showing. So in this case, there would only be 2 bars. There would be one for the male responses, and there would be one for the female responses. And mind you, I just drew some random bars. Those are not accurate. For me, the visual is helpful. This one would have 5, representing only females. This one only represents that one specific response, comparing male to female. Now, I think that there's one of these that maybe makes a little bit more sense. Which response or which graph, the one on the left or the one on the right, do you think is more helpful? Would it be more helpful to have in blue, one for female, one for male? Or would it be more helpful in green to have 5 different charts for each of the responses? One for female, one for male. That's how we decide what to condition on. So that's what that question is. How do we decide which variable to condition on? This is what you've done before. Think about explanatory versus response variables. So the explanatory variable in our case, probably what is affecting the other one, probably gender, might be related to the chance of getting rich. So then we would condition on gender. Okay, we're going to look at another data set similar to that and talk about how we would construct a graph to compare the two distributions. Okay, so next thing that we're going to look at is what is called a segmented bar graph. You also might hear a stacked bar graph. So we have this data off to the right. I don't remember what it represents. Obviously, probably age and then something else, but I don't really care what it represents. What I care right now is using it to construct a segmented bar chart. Okay, so here's the way that a segmented bar graph or a stacked bar graph works. First, you're going to have a set of data. So I'm going to say we are going to make a graph looking only at this age group. That's all we care about. Okay, you're only going to have one bar for the whole group. That bar can either be vertical or it can be horizontal. I'm going to go horizontal just because there's more space. So I'm going to go this way. Ooh, that doesn't look very nice. I'm going to go that way. And on that axis, I'm going to put relative frequency. And it's going to go from 0 to 1. Okay, so then doing some calculations. If I look at these people right here, 146 people out of 385, that's about 0.38 of the data set. So I'm going to have to do a little better scaling than what I did. This is about 0.5. So this is about 0.25 then. So 0.38 then, say, is about here. So then that somewhat category is 192 out of the 385. That is about 0.5 of the data set. So then what I'm going to do is I'm going to start where I left off and add on 0.5 to it. So I'm going to have to get to 0.88. I know it might be right there. So I'm going to keep going. And then we're going to sum to 1. So that last category of very much would get us to 1. So this is the 18 to 35-year-olds. So I'm going to label this age. Probably would have a key. So this dark is going to be not much. I'm going to do some dots for somewhat. So if I were to put a key, solid is not much. Dot is going to be somewhat. And then that one that I just left blank is going to be very. Sorry, I didn't give you a ton of room for this. Of course, you're going to put a title on this of some kind. I'm not that picky. So I know in your science classes, those teachers tend to be pickier about what's in the title. I don't care as long as there's context. So that is a segmented bar graph. That is a perfectly viable graph just the way that it is. Now, the reason that we like segmented bar graphs, so why are they good to use, is to compare. So you might have been able to tell from the way that I've been drawing this that the next logical step might be to do another bar for that group. So let's do that. We're not going to do the third one, but we'll do the second one. So I'm going to do this time that 146 divided by the total of 531. And I get about 0.27. That's about here, let's say. And then I have to do the 260 out of 531. And that's about 0.49. So that gets us up to about here. And then again, we should end up at 1. So those are the 36 to 55-year-olds. And then again, you would probably have to do another one for 56 to 94. We're not going to because I think you get the point of it. But that would be a really easy way for us to compare the distribution of whatever question they were asked by age group. I happen to use different colors, you don't have to. As long as you know which age group is which. For your graphs that you construct, I'm going to be looking for a title and a label on each axis. So make sure you have that. Okay, we okay on that? Yeah? Okay, so we have one more thing we're going to talk about, and then this Pew Research one is the last example that we will do together. So, what does it mean for two variables to have an association? So if two variables have an association, it means that knowing the value of one variable helps predict the value of another. Okay, for example, if I were looking at grade level and job status, let's say part-time job. So I'm looking at high school grade level and job status. And let's say that job statuses are, I don't have a job and I've never had a job. I only have a job during the summer. I have a job during the school year. If I tell you someone's grade level, like I tell you I have a student at random and that student is a freshman, does that give you any information about their job status? Okay, so would you say that a freshman is equally likely to have a job to a senior? I would say my guess is probably not. That seniors are more likely to have a part-time job outside of school than a freshman is. Is that a pretty accurate statement? Okay, so these two then, we would say are associated. Right? If I tell you someone's a freshman, they're less likely to have had a job. So they are not associated. Now, instead, if I look at grade level and favorite color, this time I tell you I have a student who's a sophomore, what is the likelihood that their favorite color is yellow? Does the fact that they're a sophomore have anything to do with their favorite color? Probably not. Probably not. So I would say that the job status is associated, the favorite color is not associated. Now, it's not always super intuitive. There are associations that exist that don't necessarily make sense, they just happen to exist. Okay, so looking at the graph that we wrote above, we're looking at age versus a response to some question. Looking at the graph, do you think that there is an association between those two? If I tell you someone's age, does it give you any information about how they might have responded to this question? Yeah. Augie, how can you tell visually?
Because they're different.
Because the graphs are different. Yeah, if I tell you they're 18 to 35, they are much more likely to have said not much than if they were 36 to 55. So how can you tell by looking at a graph? Simply, the graphs are different. Okay, questions before our last example, which does have parts A through F, so don't get too excited. We're okay? Okay, the plan for this last example. I am going to do parts A through D with you. You're going to do E and F. So let's start. The Pew Research Center asked a random sample of 2,024 adult cell phone owners from the US which type of cell phone they own, iPhone, Android, or other, including non-smartphones. Here are the results broken down by age category. One thing I want to point out to you, 2024 does not refer to the year. I think naturally we read, oh, we're talking to adults this year. How do you know we're not talking about that 2024 does not refer to the year? It's the total in the table. So that's something you got to pay attention to. Okay, so part A. What proportion of iPhone users were 55 or older? Proportion is a decimal. When we say of iPhone users, we are only looking at the 467 iPhone users. So we're only referring to these 467 iPhone users. The ones that are 55 and older are 127. You could certainly leave your answer like that. I don't like to because it doesn't, like conceptually, I can't look at that and know what it is as a decimal. So I will normally convert it to a decimal, so that's about 0.27. B, what percent of 18 to 34-year-olds owned Android phones? So this time, we're only looking at the 517 18 to 34-year-olds. So this time we're looking vertically. And out of those 18 to 34-year-olds, 214 owned an Android phone. Now, one thing I want you to pay very close attention to. Part A asked you for a proportion, which is a decimal. Part B is asking you for a percent. I will be picky on that. So you need to make sure that you express your answer the way that you were asked. So this is about 41.4%. Okay, so then C, display the marginal distribution of cell phone type. What that means is we only care about cell phone type. Age doesn't matter to us. So we can either do a segmented or just a plain old regular bar chart. I'm going to be honest, I don't really love segmented bar charts, so I don't make them unless I have to. So I'm going to make just a plain bar chart. So we have phone type. And like I told you, I prefer to do frequency because it's easier. So we have iPhones, Android, and other. Class is done, isn't it? You guys are such nice, polite people. I thought we were just going to keep on rolling. Okay, here's what you have to do. I'm so sorry to take you long. You have the 1.1 time. We'll finish these notes Tuesday, you have 1.1 practice. It's a worksheet on Schoology. So sorry to keep you. Thank you very much